Luckily for you, I made it a different video because the other one was already at 21 minutes. Oh my gosh. Okay, volume. How much space something takes up or how much space is in a container. So there's two kinds of volume. Like for instance, well, even this, the vial situation. Like this vial, it takes up a certain amount of space. I mean, the fact that it's made of glass and it has a cap here. So this stuff itself takes up space. But there's also an empty cavity, a space inside the vial. So there's two kinds of volume. The glass itself, the cap itself, again, the plastic that makes up the cap and the glass that makes up the vial, that matter takes up space. But it's arranged in a way that it's kind of like a container. Like even the cap has a volume inside there, a space that you can put stuff. And inside the vial, again, there's a space that you can put stuff. And so there's two kind of ways we describe volume. The space that the actual matter itself takes up, or the space that's inside a container that you could store things in. So we'll probably be looking at both of those different things at different times. And we'll be looking at measuring some volumes of some objects, like the volume of a box. How do you find the volume of a box? They told me length times width times height. I agree. So that means in class you're going to be measuring some dimensions of some containers, some boxes. That means it's centimeters times centimeters times centimeters, which we call centimeters cubed, a cubic centimeter, which is about, let's see, about this big. A cubic centimeter is about that big. That is 1 centimeter by 1 centimeter by 1 centimeter. That's a cube. That's 1 centimeter cubed, 1 cubic centimeter. That's how big it is. So we'll be measuring dimensions of these containers with a ruler. And let's see. There's also cylinders. I have some containers that are boxes, some containers that are cylinders or cylindrical, you could say. How do you find the volume of a cylinder? Well, it's the area of the base times the height. What's the area of the base of a cylinder? What shape is the base of a cylinder? A circle. What's the area of a circle? Pi r squared. Maybe you remember that, maybe you don't. I mean, I know you've learned it before. So again, this isn't anything new, but that is the area of the base of a cylinder. Times the height of the cylinder tells you the volume, how much space inside. Hopefully you're still with me. So that's what we're going to be doing. Now, think about this. Radius is measured in what? Centimeters. You're going to square it. That's what the formula says. You're going to square it. What's a centimeter squared times another centimeter? That's centimeters cubed. So either way, whether you're measuring volumes of boxes or volumes of cylinders and you're calculating them, then you're going to get a value of volume in centimeters cubed or cubic centimeters. Now, what is another way we can figure out the volume of the space inside a container? The space inside a container. Someone suggested we could fill it with water and then measure the volume of the water that we put in there. And I agreed. So we have a water-filled method. And that might look like this, where you have like this box and you're going to take a graduated cylinder with a known amount of water in it and you're going to pour it into the container until it's full, keeping track of how much you've poured in. The suggestion was that you fill up the container and then pour that water into something that you can measure it. I said we should probably do it the other way around, because if you have a container full of water and you try to fill that up and then carry it somewhere or even pick it up and then pour it into a container to measure it, you're probably going to spill it. If y'all can't put sugar in a vial without spilling it, I really don't think you're going to be able to pour water out of a full container into something else to measure it. So my suggestion was to start with a graduated cylinder that has a known amount of water in it, pour it in until the container is full, and then you'll know how much you poured in. That's how much volume inside the container has. That's going to be measured in milliliters. And the end goal here is I want us to compare how does a centimeter cubed volume measurement by getting dimensions like we're doing here, getting dimensions of the cylinder or dimensions of the rectangular box. how does getting those dimensions compare with the water-filled method and measuring in mLs? So we will then, after we get that data, we'll make a graph. Of course, we took a little break from graphs for the mass. We did particle diagrams. Now we're going to go back to graphs with this data and compare how a centimeter cubed compares to a milliliter. All right, dealing with volume. So that's what's going to happen next. And so the next time y'all are in here, we'll be measuring all those containers. We just barely started measuring those containers today. So we'll have to finish measuring all those things, and then we'll compile the data, and then you'll probably have another video telling you what to do with all that. So that's the next lab we're doing. Hopefully, if you're not here, you'll be back soon. And hopefully, if you're not here, you're actually watching these videos that I'm putting on here for you to be caught up and not be behind when you come back. So take care of yourselves. We'll talk to you later.